Okay, so I'm gonna do some of the problems that was requested from class. So remember, if you go into the course page, you can go to any of the Hawks assignments. So I clicked on Chapter 1 Review, and once you do, it'll bring up the Hawks window. And so just to recap, uh, these are just optional. You can do the section problems, or you can do the chapter reviews. The chapter reviews is the only thing that is included in the grade. So I'm just going to do some of the chapter review questions. Again, the learn kind of walks you through the material, and then the practice gives you practice problems. That's what I'm going to go. I'm not going to go into certifying. Just so you know, the practice problems and the certified problems are exactly the same. So let's get started on chapter 1. And so in case you forget what chapter 1 was, chapter 1, let's get the official name out of the book. Critical thinking and problem solving. So I think in this video we'll go through chapter 1 and chapter 2 if I have time. And I'm not going to do all 18 problems. I'll pick a couple to do. So if we're looking at this sequence, right, you can see there's a pattern here, right? So I go from 1 to 10, 1 to 20, sorry, and then 20 to 40, then 40 to 80. And what you can see here is this is by pattern. Sorry, I'm trying to find my pen. To go from 1 to 20, I 10 to 20, sorry, I multiply it by 2. 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. So 80 times 2, get on my pen, is 160. And then 160 times 2 is 320. So I believe that to be the pattern. And remember, geometric is when we multiply by the same number over and over again. And so arithmetic is you add the same number. Geometric is you multiply by the same number, and it may still have a pattern, but it could be in either problem. And get rid of my pen here. Sorry, there's a little delay here between the typing and pen. So here's another one, right? So 3, 6, 9, 12, 15, and 18. I am adding 3 each time. So that is an arithmetic. All right, so before the election, you want to determine the number of possible president, vice president combinations that the clubs belong to. If both positions are chosen from 11 people, how many combinations are there possible? Right? So the way I would do this one is, even though we haven't talked about it yet, there is a key on your calculator that is an NPR. And we'll learn a lot more about this in probability, right? And that's why I picked this problem, not realizing we haven't talked about this yet. Where N is how many people are in the sample. So there's 11. Permutations is the key you want to use. And we're picking 2, right? Just the president and vice president. Yes. So we're picking 2. So usually this is under the probability key, or it may be on the front screen of your calculator. If you have it, or under maybe the math key. So the calculator I'm on, I think it is under math. It is not. So there it is, right in the front of the calculator. So on TI-30X is right in the front, NPR, NCR right in the middle. So you put in your N first, 11, get to the P key, and then put in 2, and the answer is 110. Right? So that's using technology. So if I want to see how they would want me to do this, even though if I'm using technology, so find this key on your calculator for this problem, because by the time you take the test, we're going to have probability anyway. So if I click on tutor, oops, let me clear my drawings. Annotate clear so I can show you how to use the tutor button as well. Clear my drawings. I think, again, I believe the answer to be 110. So if if person, this is how the tutor key works. If person A is president, how many options are there for vice president? So remember, there's 11 people. I picked one. That means there is 10 possible people left I can pick for president. Right? Carry out the plan. With person A as president, there are 10 choices left for vice president, making 10 different combinations. All right, so let's assume B. How many are there? So A's back in the mix. So then there's also 10 again. And so there always will continue to be 10. So use this pattern to determine the total number of presidents. So there's 11 total, 10. So I just multiply 11 times 10, which is 110. And there's how you can also get the answer. So thinking through a process helps as well. So to do it, so the permutation key I showed you, or the tutor key, is a great way, but there is the pattern because you're losing one every time. Now, when you do more than one, it gets much more complex. That's why we'll learn about permutation key later on. So, I'll let you kind of work through that one. I haven't had a lot of questions, but we're basically taking the information you're given and finding the missing piece. Let's skip that one. I want definitions, you can look them up. So remember the estimating. When they tell you to estimate, you round the whole thing. So this should round to 70 times 50, right? Because round up, round up. So 70 times 50, oops, 50. It's 3,500. So remember, I want you to round both, not just one answer. That's how Hawks explains the rounding rules, and it's a great word for estimating. But there is times, like I said in class, that I will only round one. But again, that is completely up to you. All right, which one? I'm looking for a specific problem. I've had lots of questions on here. So next, get rid of my drawing. Sorry about that. Another pattern problem. I'll let you work that one. Like I said, I'm not going to do them all. This is reading a graph. All right, so for this one, the trick here is you take these two numbers and kind of add them together, right? So what I mean by that is if you take 550 and then multiply that by 551, which is just 550 plus 1, right? Say 550 plus 550, no, not plus, sorry, 550 times 551 gives me 303,050. And you think about the way we're adding, right? And when you add two numbers, multiplying is just adding the same number and over again, right? So if I cut this in half, I will get the answer. Go to my drawing, which is 151,525. Right, and so the reason you cut it in half, think about this. If I'm adding up all these numbers, the pattern here is I'm going to add 1 plus 550, right? Because we're adding up all the numbers from 1 to 550. Then my next pattern, 2 plus 4, no, sorry, 500, ugly 5, 49. Because I have already had those numbers in 3 plus 548. Notice we're adding two numbers, and by this pattern, there's where the 2 comes from. And then because I am increasing by 1 on this side every time, but decreasing by 1 at this time, this little trick of multiplying the two numbers together will assist in finding the answer. All right. Next, you can round. let you work on the word problem. Definitions. That's another Go problem. Remember the magical square? We did this in class. Can only use the numbers once. And they even tell you what it has to add up to in this problem. All right, so this is what I'm getting a lot of questions about for this set. So it says to write it out so you can see a pattern. A lot of them, let's try similar. I want the 3-1. That's what most of people. No, it's just going to keep me at 2, so I'll do 2. A lot of you are getting the 1 to the 3rd power that keep emailing me. But if you write these out, so 2 to the 1st power, 2 to the 1st power is 2, because anything to the 1st power is itself. 2 squared is 4. 2 cubed is 8. 2 to the 4th power is 16. 2 to the 5th power is 32. 2 to the 6th power is 64. 2 is not too bad to do in your head because it's just doubling every time. 2 to the 7th power should be 128. I'll check my math just so I don't confuse anybody. And you have this key on your calculator, depending on what calculator you have. On the Texas, it typically looks like a little caret key. Other calculators will have an X with a box or something with a box. Those are how you do the powers. And then 2 to the 8th power, 256. So you can see here, and 3 is going to kind of work out the same, where you're going to find a pattern of 4. Notice every 4 iterations, the numbers repeat. So 2, 4, 8, and then in the ones place is a 6 on 16. And then we come over here, I'm in the 2s in the ones place, then a 4, then an 8, and then a 16 again. So every 4 numbers, the ones place repeats. And so what I do is I take my exponent of 2018, and then I divide it by 4. So because it repeats every 4 numbers. This will tell me what iteration I'm on. So 2018 divided by 4. In this case, it does not work out nicely. It is 504.5. Well, since 4 doesn't go on, that means I didn't complete the iterations, but 8 is an even number. So therefore, I have to be in the 2nd iteration. So even though I don't know what this whole number is, I know the number in the 1 spot is a 4, because that is the number that is right here, right? If the 4 would have gone into it, so say that was 2022, and I divide that by 4. Oh, I'm sorry, I went up too far. 2020 divided by 4. That does come out evenly. 505. And then I would know I'm at the end of the iteration, and the number in the ones place would have been a 6. And if it had been an odd, depending on where I was at in the process, I could figure out if it was a 1 or a 3. So again, this 4 doesn't go in evenly. So I know I'm not at the end of the iteration. It is an even number, so therefore I know I'm in the 2nd step of the iteration. So the number in the ones place is a 4. So I know I did skip some problems, and I've gone through and done kind of the tough ones. I left a little bit of the word problems. So give them a try, and so we can see how those work. So there's a quick rundown of Chapter 1 review. Clearing up my notes here. And I haven't certified, I haven't gotten certified. So just save and exit, because I'll keep track of your progress. You can go back and keep working on it. Go back to View and Life Mathematically. I am going to go over, remember the bonus sections are for you to practice if you want to do each section individually. The only sections I'm looking at for you to have to complete is the projects, but again, the projects are, the chapter reviews, but that's only if you want to do them instead of the projects. If you prefer to do the projects,